Okay, so sticking with the program here, section 6.3, this is example number 8, finding the component form of a vector. Find the component form of the vector that represents the velocity of an airplane descending at a speed of 100 miles per hour at an angle 30 degrees below the horizontal. I drew out a diagram for you. Now, it does say 30 degrees below the horizontal. This is a horizontal. So this angle right here is 30 degrees. That's your reference angle. All right, so what in the world am I going to do to start off with this? Now, I want component form, which means that I want to know what is the terminal point. What is the ordered pair for this terminal point? All right, so I'm pulling from a formula that I have. This is from your guided notes, section 6.3 in your guided notes. It's near the end. And I'm using this formula right here. Okay, the magnitude times the cosine of the horizontal component plus the magnitude times the sine of the vertical component. Okay, so that's what I'm using. Now, first thing I need to know is I need to know what is the cosine of a 30-degree angle, not the 210, but of this 30-degree angle. Now, I do know it is in quadrant 3, so I know cosine will be negative. So it's going to be helpful for you to know and still always know your unit circle. This is a 30-degree angle. In the first quadrant, it has an ordered pair of square root of 3 over 2 and 1/2. So I know, on this, for this angle, the cosine is equal to, the cosine of a 30-degree angle is equal to the square root of 3 over 2, and the sine of a 30-degree angle is equal to 1/2. Now remember, we are talking about a third quadrant, so third quadrant, both sine and cosine are negative. All right, so let's just remember that because I'll transfer it over here. Let me go ahead and write down this formula here. So the magnitude of vector v, we can call this vector v, times the cosine of a 30-degree angle times I plus the vector, magnitude of vector v times the sine of a 30-degree angle times j. All right, so let me go ahead and fill in what I know. All right, so magnitude. Well, the speed is 100 miles per hour. So in 1 hour's time, the length of this vector is equal to 100 miles. So I know that the vector is, magnitude, I keep saying that. The magnitude of vector v is 100. I also know that the cosine of this 30-degree angle in the third quadrant is negative square root of 3 over 2. We'll leave the I. Plus, again, the magnitude of that vector is 100 times the sine of that 30-degree angle in quadrant 3 is negative 1/2. We'll keep the j. And let's go ahead and multiply here. So I know that 100 divided by 2 is 50. So that's going to be negative 50 root 3. And obviously here, 1/2 of 50, of 1/2 is 100 is a negative 50. J, I'm going to change that over to a minus sign soon. So this is your horizontal component. So we're going to the left 50 root 3 units. Then we're going to go down 50 units. I want this in component form. There's your component form. And when I write it in component form, I'm going to leave the I and the J out. All right, so there's your component form of that plane. This basically tells me where will the plane be based off of this coordinate plane. Where is the terminal point of this plane at after 1 hour of traveling? Now, if I wanted to double check this and make sure that it has a magnitude of 100, again, I can use your distance formula. Since I know the initial point is 0, 0, so this minus 0 will give me this. Square it, plus This minus 0 is negative 50. Square it. When I square this, okay, so let's take a look here. First off, when I square the, I'll just go and type it in a calculator. 50 root 3 is going to give me that value squared will give me 7,500. 50 squared is going to give me 2,500. Yeah, I don't care that's negative because it's going to end up being positive anyway. 7,500 and 2,500 should give me 100,000. I'm just going to add it. 10,000, sorry. And what's the square root of 10,000? All right, so everything checks out. So that is example number 8 from section 6.3. Next video I will do will be for example number 9. So if you have any questions, again, please reach out.